Okay, so Doug Guzet again. Welcome back to Caves and Speleology, Missouri Caves and Speleology. And today I'm here to talk about speleothems. This lesson I thought we'd talk about those. What are speleothems first? It sounds like a big, 50-cent word. It's really just the word we give to any formation, rock formation or mineral formation that grows inside a cave. We typically call that a speleothem, them kind of being the part of the word for a growth and speleo being the cave. Most of us have probably, especially if you've ever been to a tourism cave anywhere or studied much about caves before, you've probably heard of people telling you to watch out for the stalactites and the stalagmites. The stalactites hang tight to the ceiling, and the stalagmites are on the floor and might grow up to the ceiling at some point. And those are still valid, good words to use, but we give a lot of other terms. Every show cave has its own lingo, if you will. If you go take a cave tour, they'll probably tell you about the Elmer Fudd formation and the special Kathy Rigby formation or something like that. And that's usually part of the history of the cave and the tour and who discovered that particular feature, who named it Donald Duck or whatever. But really what people like is that these speleothems usually are what are the very shiny crystals or pretty stuff that give people the oohs and ahs when you're in a cave. So I'm going to kind of go today using mostly Will White's 1988 textbook. We've put that book in other things in this class. We've used it as a reference. Will White's a very famous karst person from Penn State, and he came up with three main categories for the way we look at speleothems. And that's because as scientists, we're not here to discriminate. We don't want to stereotype, but we do like to categorize and classify things. We like to give everybody their mailbox address or their zip code because that's part of how we can keep track of all the different things we've discovered in nature. So the first three categories that Will had were dripstone and flowstone, putting those together, things where water is dripping or flowing. Subaqueous, things that are growing underneath water that's either flowing or in pools. And then he just gave a third one that was called erratic, oddities, things that were either very complex or just unusual and didn't really fit those two other categories. So let's look at these together in a little more detail. First, I want to repeat that all speleothems, all the things that deposit in a cave other than bat guano and some of the bug things, all the minerals are things that are crystallizing or solidifying out of the water, and they're doing it because the water is what we call supersaturated. It is over full of that dissolved mineral for the amount of water left. Either sometimes some of the water has evaporated away, or as it drips into a cave, sometimes the CO2 gas that's in the water will bubble out or join the air in the cave. It's kind of like opening a can of soda and watching the bubbles come out. That changes how thick the syrup left behind is, how thick the consistency is. So as we look at these dripstones and flowstones, let's look at a stalactite. It's a pendant-like thing. It hangs down from the ceiling, and it's got a central core of water. In other words, as the drip starts to come in from the ceiling, that drip, as it off-gasses, will leave usually a little rim. It's kind of, if you live in a place with hard water, it's like the little rim of mineral deposit you get left on your faucet. And over geologic time, that dripping through the roof of a cave will give you what we call a soda straw. And it will give you a long mineral thing that has water now dripping down the middle of it. A stalagmite is usually a column or a mound, I shouldn't say column, that's a different feature, a mound that builds up from the floor that if it's dripping fast enough, gravity will pull that drop to the floor before it loses its gas, before it loses some of the CO2 and starts to build mineral deposits on the floor, and that is a layered, wet on the outside mound that starts to grow up to the ceiling, up to where stalactites are. And in fact, if a stalagmite and a stalactite meet, they're usually called a column because they become a consistent vertical pole, if you will, just like a column on a courthouse. Then there's another type called a drapery. It's sheets of solid mineral phases, usually have some water on the surface of them still, and they're formed by the dripping and trickling water that's coming through usually along a fracture or along the walls of a cave and so they grow out from the walls. If you take almost any commercial cave tour, they'll often show you cave bacon, which is where a thin plate of that calcite mineral will be attached to the wall, and if you hold a flashlight behind it, it might look like bacon that you could have with your breakfast. There's other flowstone, just layers that are formed by flowing sheets of water that, again, as they lose little bits of gas, leave little bits of minerals behind. And there's actually a thing called a crust. It's a coating, usually of a gypsum, which is a little more shiny than calcite sometimes. You could think of a geode. If you've ever opened a geode and found crystals lining the inside of a hole in the rock, that would be a crust of a sort. Let's talk about the subaqueous things. A rimstone dam, it's much like that drapery. It's where, as I have a pool of water or even sometimes a stream that's slowing down, especially if it's slowing down over a little riffle sequence, I could lose enough CO2 gas that I would build up a little itty-bitty layer, and sometimes they actually kind of accumulate as a little wall, not necessarily a straight line or anything, but just a wall. And that becomes, over time, a dam that usually often builds a pool of water behind it, which just keeps feeding it with little bits of calcite as they add in. There's crystal linings, there's coatings in pools, or even the entire cave might be coated. One of the pictures we have on the wall here is the crystal lining of a cave down in Texas. So rimstone dam, crystal linings, these are all forming while they're still underwater, but the water is so supersaturated. And maybe I should say supersaturation is just like taking a bunch of, I lived in the South for many years in Atlanta, and many restaurants had sweet iced tea. And if you were in the habit of also pouring sugar in your iced tea, you could sometimes make that so sweet that as you poured a little more sugar in, the crystal might start to melt or dissolve, but it would make the tea so sweet that some of the other sugar in there would actually precipitate out. The sugar molecules, the atoms, would find each other and bond and drop to the bottom of the glass. That's why people stir their iced tea, to keep the sugar in there if you want it really sweet. Concretions would be the last type of subaqueous thing. They're concentrically layered, they're unattached to anything. They just kind of start forming in a pool of water. And they could have a rough surface, but often they have a smooth one, and we often call them cave pearls, that if you have a growth that, as maybe a little water sloshes back and forth over time, or as currents of water flow in, it might just kind of roll these around, and it's literally just like a pearl in a oyster. It just builds layer upon layer of calcite on top of it. Well, let's talk about some of these erratics, the oddities, if you will, are things like a shield. That's a speleothem feature where it's sort of a disc-like solid piece of rock that usually has a crack in the middle. Maybe there's water pressure underneath it that's bubbling up, and so I might get sort of a disc with a crack right down the middle, and it just accumulates stuff. I get halictites. These are usually really cool, and I know I'm going to have some pictures up on the Blackboard site with those. They're curved stalactites. Sometimes there's air currents in a cave that make the stalactite curve. Many times what it is that soda straw that has the rim of calcite with the hollow core of water dripping through. Many times, somewhere over geologic time, a little piece of grit or a little less soluble piece of calcite will stick in there and maybe clog up that hole that the soda straw's in. But then it backs up the water, and the water that's still dripping through from the surface will push through the side and find a way out, and it will continue to grow to the side. So sometimes they grow kind of helical, or sometimes they grow kind of perpendicular and spidery off to the side, and we call those halictites. There's also a botryoidal shape, things that look like a cluster of grapes or beads and knobs, that kind of stuff. There's an anthodite. It's a radiating cluster of crystals. Some caves will call these a mass of snowballs, or gypsum flowers. They're very pretty sometimes. Sometimes they're very dendritic, sort of like the branches on a tree. They kind of radiate out from a central area. And again, these are just formed by a complex thing, not just simple dripping or water flowing. And the last, but certainly not least one that I want to mention is a thing called moon milk. It's a loose powder or sometimes a wet pasty mass. It's often a mineral that is actually hydrated. If you think about it, you could make paste at home by taking something dry and solid like flour and mixing water in. Well, if you let the flour dry out as paste and solidify, you could actually put more water back in and you might get it to be kind of mushy or goopy again. And that's what moon milk looks like. It's crystals that are forming, but they're not completely dry and they're not completely wet and dissolved. I will notice that the other text we've often referred to, Art Palmer's excellent cave geology book, Art even breaks out one more category, wind impacted or wind formed. There's a national park up in South Dakota, Wind Cave, and another one nearby, Jewel Cave, and both of those have very good air currents blowing in and out, and so that has made some of their halictites grow sideways. It's made some of their formations do some very unique things, and so sometimes other scientists like Art Palmer might say that's a fourth category rather than the three that Will White used, but they're all very similar. So what are speleothems made of? Well, they're all made of these carbonate minerals. Mostly they're made of calcite, sometimes, which is the calcium carbonate that we've talked about before. Sometimes they're made of another mineral called aragonite, and that's unusual because it's also calcium carbonate. It's just a different crystal system. It's a different way that the molecules actually, the atoms actually bonded together with their electrons and the protons. And so aragonite and calcite are the same chemistry, but they are slightly different crystal shapes and designs. And it turns out probably close to 95% of the speleothems you'll ever see are one of those two minerals. There are some other ones that are out there. We've talked about dolomite, the mineral that makes dolostone. It's a mixture of calcium and magnesium with carbonate. There's actually another mineral called magnesite, which in, again, some very famous national parks in the U.S. make a thing called hydromagnesite balloons. It's where the magnesite has stayed almost like moon milk and water has kind of made a large, almost balloon out of it. Magnesite is magnesium carbonate rather than calcium carbonate. There's even another mineral called siderite, which is iron carbonate. It turns out, if you're into chemistry and crystal formation, that having that CO3 means there's a lot of other atoms in the periodic table, if you ever look up one in a chemistry book, that have a 2+ that can fit right in there. Calcium, magnesium, barium, strontium, iron. Many of these things will fit in there and give us a carbonate. So speleothems are mostly 90 to 95% calcite and aragonite, calcium carbonate, but any of these other carbonates often will form a speleothem too. And with that, I'll stop there. I'll say enjoy some pictures. I'll put some of mine on the class website on our Blackboard site. I'll also encourage you to look in several of the textbooks that we've linked to or referred to, or even things like the Caring for Karst brochure, and even just go to any national park cave website. You'll probably find one or two beautiful pictures of some of what they have. I will say Art Palmer's text has some excellent photos. There are all in black and white, but they're outstanding pictures, and again, you'll see just wonderful examples of all these different categories of speleothems. But the biggest thing is just to remember that it's water dripping in or rolling through the cave, and that as it loses little bits of gas, it's going to leave behind calcium carbonate, either as aragonite or calcite, or occasionally some other carbonates. So that's where I'll stop for today. That's the end of our speleothem lesson, and we'll be back soon. Thanks.